Right, so the first thing that we're going to do in proving all the trig functions is we're going to remember what this means. So if we have a reference angle of 0, go up theta, we call this, instead of xy, we called it cosine theta, sine theta, because sine was the y, cosine was the x. And we're not going to prove sine and cosine, they're just kind of definitions which we got before. But that's because this is cosine and this is sine of theta. Is that all right? And then this is going to be 1 because it's a unit circle. And let's see. Got that? Okay, good. Now, this is a right triangle, so we're going to draw it right here. Did I say right triangle right here? I didn't mean that. But 1 cosine sine. Now, what do you know about right triangles and their lengths of their sides? Marius, what do you know about that? The length of sides and like A, B, and C on a right triangle. They go together. How do the 3 sides with a hypotenuse and 2 sides go together? Stanley, what do you think? Don't scare me. This is early algebra. How do these 3 sides relate on a right triangle? Pythagorean theorem, sure. So.
I thought you were asking for like 1/3 of the side.
Oh, no, we don't know that yet, but we'll get there. So we're going to go 1 squared is equal to sine squared plus cosine squared because they're on a right triangle. This is the first of 3 Pythagorean identities, and if you ever need to know this for a test, one of your student colleagues of the past made this nice sign up here. It says, if I am sine squared and you are cosine squared, then together we are 1. I thought it was so great because it's kind of our school slogan, and it applies to this Pythagorean identity. All right, so that's that one. Now, I wouldn't do this, but if I were to take this meter stick and just gently tap Sana on the top of the head, I would never do that, but this point shows a what line on the edge of her head? What would that be? What do you call that line? It's a tangent line. It skims. It has 1 point of contact with the curve. And so we're going to draw a tangent line from the circle. I'm going to move it just a tad here. And then I'm going to take this one and move it out to here. And this is a tangent line that has, I want a different color here. Here we go. It has a right angle right here. Now, this has a name. This, that's got purple already. This has a name, and it's called the tangent of theta. And that is all the way from here to the x-axis. That's called the tangent. And then from the origin out to where this tangent line hits the x-axis is called the secant of theta. Those are geometrically what they mean. So tangent goes from the point xy, tangent to the circle down to the x-axis, and then from that point to the origin is called the secant. Pretty cool. And that is also a triangle. So I'm going to draw it. Looks something like this. It's got a little right angle. It's got a little angle theta here. But what's different is that this now is the tangent of theta. This is the secant of theta. That is still 1. Now back in geometry, long ago, you saw that if you have 2 right angles that are the same, 2 angle thetas that are the same, what will these 2 angles be? The two right angles are the same. The two thetas are the same. What about these two non-labeled angles? Same. So that means all the angles of the triangles are the same. That means they're special. They're similar triangles. And similar triangles will allow us to do something called a paired ratio or a proportion. So we're going to go, for this one, I'm going to take tangent over 1. Now from theta, it's straight across, tangent over, this one is next to it, but it's not the hypotenuse. What do we call next to it, but not the hypotenuse? That's called the adjacent, okay? So let's go to this triangle, because they're similar, we'll have the same ratio will be equal. So straight across is what? Sine of theta. See where this is coming from? And then next to it, but not the hypotenuse, is the cosine of theta. And we just defined what tangent is. Sine over cosine. It's proven geometrically. Bam, right there. Oh, let's go one step further, but you're going to do it this time. I want you to use this triangle again, but we're going to do secant theta over 1. All right, so for tangent, that's straight across over, oh, tangent. I didn't want tangent there. I wanted secant, secant, which is the hypotenuse. What's the hypotenuse for this top triangle? 1. So we're going to have a 1 here over, and then for this triangle 1 is just this one that's the adjacent side, not opposite. So what's adjacent, not opposite? Cosine. How are we doing? Secant is 1 over cosine. There's another definition that you're going to be responsible for. You'll memorize it, but I wanted to show you where it came from. And then as a bonus, we're going to say, okay, Pythagorean theorem, secant squared theta is going to be equal to 1 plus tangent squared theta. What do you know? There's a whole bunch of formulas there. Move all this quick. There we go. All right. So we have one more triangle to make, and that triangle we're going to start at this place. Remember when we went tangent? We're going to go the other direction to the other axis, the y-axis, and this is going to have a wacky name. What do you think it's going to be called? If this is the tangent, you got it. It's the cotangent. There it is, cotangent. And this one here, from the origin up to where that cotangent hits the y-axis, this is going to be called the cosecant of theta. Just draw those in quick. And that will help us draw our very last triangle. That's this one, which has a right angle. And it also has something else going for it. I'm going to show you that in a moment. Okay, this has a right angle. Let's say this angle here was 30. What would this angle be? 30? This would be 60. What would this up here be? 40. If this were 20, this would be 70. This would be 20. If this were 10, this would be 80. This would be 10. What do you notice about these two angles? Theta and this one are the same. And what will the third angles be? The same. So therefore, what you're going to end up with are two similar triangles, actually three similar triangles. This one has a cosecant theta. It has a 1 down here and a cotangent theta right here. So now with this, these have the same angles, all right angles, all thetas. Third angles will be the same, they're all similar. So you can do the last of these, cotangent theta over 1 and cosecant theta over 1. This is a time to wrap this up. So cotangent, if I look at cotangent, it's the adjacent next to the theta. So the adjacent next to theta here is cosine. And did anybody get cosine over what? Didn't get it? Where's 1? Hypotenuse or straight across? Straight across. So it'll be over sine theta. And cotangent is cosine over sine. It's also adjacent, which is 1 over opposite tangent. It's also 1 over tangent, which you can kind of see. And then cosecant, the last one, hypotenuse, which is 1 over opposite, which is sine. Now you have the cosecant. And then the last formula will be this one, Pythagorean style. You'll have cosecant squared is equal to 1 squared plus cotangent squared. And these are the 3 Pythagorean identities we'll use next week. These are the trig definitions that you're going to use. These will all be memorized eventually, but we'll work on them so much it won't be an effort. So how do we do these in a problem? No sweat. We can do that easily. What we're going to do is we're going to take something we know, the unit circle, and you're going to use your unit circle to find out what these are. So tangent, for example, is the sine of pi over 4 over the cosine of pi over 4. So whenever you see tangent, you go sine over cosine. This is one of your problems. Would you write it with me? So you have it. And then would you look on your unit circle, what is the sine of pi over 4? If you peek at it. And I don't have one handy, but it's 1 over root of 2, right? And then so is the cosine, 1 over root of 2. So what's 1 over root of 2 over 1 over root of 2? 1, yep. So what I would do is do the formula first, break it down into sine and cosines, use your unit circle, and then get your answer algebraically. So break down first, then unit circle, next, and then calculate. Let's try the next one, secant pi over 6. Well, secant pi over 6 is 1 over the cosine of pi over 6. Okay? Somebody look on your unit circle. What is the cosine of pi over 6? Square root of 3 over 2. Yeah. If you're looking at that, you just find it on the unit circle. I've got some unit circles here somewhere. Thought I did. There's one. Thought I had a little one somewhere. Teeny tiny one. There's one somewhere. Okay. So then this is going to be square root of 3 over 2, but it's 1 over the square root of 3 over 2. So you're going to put 2 over the square root of 3. Or some people go 2 square root of 3 over 3. Either answer is fine. You do cosecant right now. Find the formula and then use the unit circle. See if you can get the answer. Last one. Cotangent is the cosine of 4 pi over 3 over the sine of 4 pi over 3. And you just use your unit circle. Unit circle 4 pi over 3 is going to be about here. I think it's going to be negative square root of 3 over 2 divided by 1/2. And those are both negative, so they're going to cancel out. 2's will cancel. I'm just going to get the square root of 3. Positive. Anybody else get that? I know you didn't have a lot of time, but so you're going to work on those. Work on these. Do some more practice with sine, cosine, tangent, and you're all set.